So for this, we will go to the Notepad++ once again. I will create a new file and first I will save this as, so we will use this TestBench folder. Now give it some name. So this is sync_testbench. Now select the file type. So that is VHDL file. So we'll select basic hardware description language. Okay. Now click on save. Now I will follow the same steps. So I will copy this part from here. Now paste it. Now change the entity name. So this is sync_tb. Okay. Now write the architecture. Behave of sync_tb is begin and in the last and architecture. Okay, so now because this is a test bench, so we do not need any port declaration here. And I am also removing the generic declaration here as well. So let's delete this data. And now we will declare the component part. So for this, I will copy this section from the sync.vsd file and I will copy this here. Okay. And I will also copy it here as well. Now this is a component, not entity. So I will replace this keyword with the component keyword. Okay. So this is our component declaration. And now we will define its input output port as signal, right? So we have this signal clock, we have this signal reset, we have this signal async, and we have this signal async out, okay, in the last semicolon, right? Now first we will generate a clock signal of 50 megahertz. So first what I will do that I will initiate this clock value with 0. And now we will generate the clock signal. So clock will be not of clock after 10 nanosecond, right? And now let's give the port mapping first to this component, right? So this is unit under test. So that is sync. We do not need this is keyword. Now this is generic map. Now because we are working on RS-232 protocol, so this ideal state will be 1, right? So this is 1. Now remove this semicolon from here. Next is port map. So this is very straightforward. So clock is connected to clock. Reset is connected to reset. Async is connected to async. And sync out is connected to sync out. And we do not need this AND statement here. Okay. Now we will write the code to drive our input ports. So that is reset and async here. Okay. So for that we will write a process block. So write it. So give it some name first. So suppose this is tb_process : process. Now I will not write anything in the sensitivity list because we are going to use wait statement in this process, right? So next is begin and in the last and process, right? And before that, I will use this wait statement. Okay. So this is the standard structure. So at the very beginning, I will apply the reset input. Okay. So what we'll do at the very beginning, reset will be high and also async, that is our input, that is again high. Okay. Because that is our ideal state. Now we will wait for 100 nanosecond. Okay. And after this 100 nanosecond, we will deassert this reset signal. Okay. So this reset is removed and we will again wait for 100 nanosecond. Okay. And now we are designing the system to synchronize our input signal, right? And because we are using the frequency of 50 megahertz, means the state of clock signal is changing at every 10 nanosecond, right? So here you can see the state of clock is changing at every 10 nanosecond. So we have waited 100 nanosecond here. We have waited 100 nanosecond here. So that's total 200 nanosecond. So there is the possibility that we are getting the rising edge of clock signal after this 200 nanosecond. So what I will do that I will wait for some random time frame. Okay. So for example, I'm waiting for another 3 nanosecond. So that's total 203 nanosecond. So that is not multiple of 10 nanosecond. So this will be a good test scenario, right? So after this total 203 nanosecond, my async output will be 0. Okay, so at the beginning of the simulation, we will have this async is 1, and that is also the ideal state as well. And after this 203 nanosecond, this async will be 0. Okay, so that's it. That's our test scenario. If you want, you can add more test scenarios inside it as well. So what I will do, I will save this file and I will go to this model sim simulator, and now we will compile it first. Okay, so for that I will add this file. So click on add to project and existing file. Now select this file. So click on browse and go to the TestBench folder, and we have this sync_tb. Now select this and click on open, and now click on OK. Okay. So we can see this sync_tb is listed here. So right click and click on compile, compile selected. Okay. Okay, so we have many errors here. So let's see. Okay, so we have this signal declaration and we have not removed the direction from this port section. So let's see how it looks now. So save this. Now close this. Okay, overwrite. Seems like it's not updated. Okay, let's remove this once again. Now save this. Now go to this model simulation and overwrite. Okay, now compile, compile selected. I think this is not saved. Let's remove it from here. Save, Control S. Now right click, compile, compile selected. Okay, now this is fine. Okay, so that's only one mistake. So we have cleared all the syntax error from our TestBench file as well. Now this is the time to simulate our VHDL code, and let's see the results in the waveforms. Okay, so we'll go to this library tab and we will see this sync_tab. So right click and click on simulate. Okay. So I am interested in this UUT. So what I need, so I need this async, clock, reset, and sync out and SR as well. Okay, so let's drag them. And now we will run our simulation for 300 nanosecond. Okay, and I think that is enough time to complete all of our test scenarios. Okay, so run for 300 nanosecond. So let's see. Now let's zoom out little. So let's see what is happening here. Okay, so till this point of time, or till this 100 nanosecond, we have reset and we have async as logical high. Okay, so this is logical high, this is logical high. At this moment, after 100 nanosecond, reset is deaccented, but async is still high. Now after 200 nanosecond, means at this point, this async theta goes to low. So this is high here, and at this point it goes to low, right? And now you can see that our output that is not changed instantly. So this is our sync out. Okay, and that is our output. So that is changing here. So let's see what is happening. So after this change, we are still waiting for the first rising edge of clock signal. So at this point, we will have this rising edge, right? And at this point, this logical 0 from async, that is captured by this 0th index, right? So this is fine. Okay, but still our sync output is logical high. It is not changed, right? So now it is again waited for the next rising edge. And at this point, we will get our second rising edge after this async value change, right? So at this point, you can see that our output is also changing. So at this point, our output is logical high. So this is logical high, you can see. And at this point, at this rising edge or second rising edge, our output changed to low, right? Okay. And you can see this value is same as sync out, right? That is changing at the same time. So we can say that our sync out is the synchronized version of this async input. And this sync out that is delayed by the two rising edges of this clock signal from this async input. Although it looks like that the data is delaying by two clock signals, so that will affect the transfer speed, right? But for this RS-232 protocol, that's actually not happening. Why? Because we are using the clock frequency of 50 megahertz, and that is way higher than the baud period of RS-232 protocol, right? So the delay of two clock frequency, that's not affect the speed of transmission here. Okay, so that's complete our synchronizer part as well. So in the next session, we will combine all the elements of UART receiver like shift register, this synchronizer, baud clock generator, everything, and then we will develop a UART receiver module.